आप
जो नाना ने खा लिया।
हेलो फ्रेंड्स, अभिलाष, निखिल, बेट्सी, श्रीराम, कुणाल, अब्दाऊ जी, How's the learning going on, Abhilash? All well?
Yes, good.
Okay. Okay, allow me
Well,
for a
good
couple of
evening.
minutes. Hi, good evening, Abdauji. How are
How are
you?
you? Good, how are you?
Yeah, I'm good too, as usual.
Thank you.
Yeah, okay. In a couple of minutes, we shall be starting sooner. Your peer mates join in the meanwhile, okay?
Thank you.
Okay, guys, the last time, do anybody remember what topic did we cover? Anybody? Abhilash, Kunal, Richard, Gopish, Betsy, Nikhil, Abdauji, anybody?
ARIMA?
Yeah,
Yes.
not Arima, but we are tending to cover Arima, but we have just started Arma in order to understand Arima. Okay, Abdauji?
Okay.
Yeah, because we understand auto regression. We understand auto regression. Gopish, if you can mute yourself. Gopish, please. Yeah, thank you. So we started learning ARIMA, but because of the time, we could only learn ARMA, auto regression, plus moving average. So we tried to understand that, okay, how come the auto regression means self regression when you are calling first lag, then second lag, then third lag in the data set. We are making it as a learning of auto regression. Means we started with, say, we already have that equation of y equals to mx plus beta, and thereby we added the, may I call, the time series data as the first lag, and then making it another function of the previous lag. So likewise, it is said that you are doing the associationship, you are finding the relationship with its own self, yes. So likewise, thereby we were having the relationship between y and x, but here we are having the relationship between the same y of t plus 1 to y of t to y of t minus 1, and so on. This is what we tried to learn the last time, and that was the part of auto regression. Therefrom, we learn the moving average. And right today, I'll just take a bit part of the PF and C partial function versus ACF, auto regression partial function, sorry, auto correlation function. And therefrom, we will continue to ARIMA model. Okay, so do let me know whether are you being able to listen to this or not. Okay, I'm sharing my screen. Selva, if you can mute yourself. S- Selva, Selva, if you are not talking to me directly, please mute. Selva, yeah, thank you. Okay. So I'm sharing my screen. Do let me know whether it is visible or no. Screen share. It's going on. Okay, going great. Here it is so. Okay. Are you able to look it?
Yes, yes. Yes,
Yeah.
sir. Yes, sir.
So
Edible.
I'm
Yes.
running it. Do let me know
Yes,
whether
yes.
the audio is sorry, audible or no. The order of AR and Q represents the order of MA. Is it audible?
No, no, it's not audible.
It's not audible?
No.
Okay, 1 second. P comma Q. So we have different choices for it. Is it audible now?
Yes, yes.
Okay, thank you. So please mute yourself unless until you have to ask the question. And if you want to ask the question, either you can raise hand or type it in a message so I could be answering you. Okay, so please listen to that. Let me explore it one by one. We can say that there are few plots called, the first option is go for ACF and PACF plot. PACF plots. What are they? ACF stands for auto correlation, auto correlation function, and PACF stands for partial, just a simple adjective, partial auto correlation function, partial ACF. So this auto correlation function actually measures, it says that I measure direct and indirect effect and indirect effects of previous time lag, of previous time lags on current value, on current value. Fine. And this is the thing that it measures direct and indirect. We will see in a while what is the meaning of direct and indirect effect of previous time lag on current value, whereby it has one more thing to say, that I used to find, how I used to find, must I say right here, used to find order of moving average model, MA model. So when you are taking the help of ACF, it is not helping auto regression, it is helping moving average model to find their order. Means it is finding the order of the errors. So if I take one example to explain, say if I remember one example, a very simple example of considering a 12th class example. Say you are, you are a kid, and I have following information basis your time series. Say your seventh standard marks, seventh standard marks are there. It was say 58. Then I had your eighth standard marks, eighth standard mark. It was 61, eighth standard. Then again I have your ninth standard marks. Say it went a bit high, 74, suppose. So ninth standard marks. And when it was a board exam, you actually scored 91%. Or say 91 marks out of 100. So this is your 10th standard. 10th standard. Congratulations, you found a good marks. You got a good marks. But sooner you dived into the 11th standard, or you have been motivated to do your 11th standard, and you found the syllabus to be very hectic, a bit of your performance went low, and you landed to manage 88 marks in your 11th standard. Now the question is, the final question is, what would be your marks in 12th standard board exam? Can you correlate your time series analysis? We are having the past values, of your marks, past values of marks of a student, and we want to find his or her marks when he or she go to the when he or she actually appears in the 12th board exam. So what's the forecasting of his or her 12th marks? This is the question. So here the 12th marks are the, see now how to apply the ARMA model. Now I'm not applying ARIMA, it's ARMA. We have not yet discussed I part. So how to apply the ARMA model? Say the 12th marks, the 12th standard marks is, if I write the mathematical model, I'll write say the first one, that is the C1, and I'll write, see this is the 12th mark. So consider this as a YT, and here with the coefficient that is C1, I'll use YT minus 1. What is YT minus 1 here? If this is the YT, I am more interested in finding the forecasted about my marks in 12th, which I am right now standing in the current year. So this would be my YT minus 1. This would be YT minus 2, and so on. Yes or no? So the marks, the 12th marks will, if I take the 1 lakh, this would be C1 into 11th marks, must I say? 11th standard marks, plus if I am more interested in, see, 10th marks also, because 10th is a pressure, the first pressure the student bears in his or her life as a board exam, although it is very easy than that of any other exam. It's a scenario of nowadays. It don't used to happen in the previous years when AI was not so advanced. So here right now I am giving a different coefficient to it and writing the 10th marks plus the error term. There would always be an error in the model. Say I'm writing C3 as a error. Okay. Or say you are also writing error term as well along with the, say this is your y-intercept and this is the error. Y-intercept means, but if even do you do not know this much of marks shall be given to you. This is a y-intercept by default given by the schools to the student, and error is belongs to model. So now the meaning is, if I want to find my 12th marks and I have my 11th marks and 10th marks and have a proper values of C1 and C2 as a coefficient, then in that case, I can apply the ARMA model to actually forecast the 12th marks, 12th board marks basis these two marks. So if you, then what is the utility of ACF and PACF here? ACF says that I measure direct and indirect effect of previous time lags on current value. So this is the current value. This is the current value. And previous times lags are this. Previous times lags, 10th marks and 11th marks. So now if I say direct and indirect, that 11th marks will have a direct impact on 12th marks. May I say it? It will have a direct impact. Direct impact, because you have just completed your 12th and all your energy, emotions, and time management, energy management, and your efforts towards the becoming or seeking a good career in today's world is associated. But you have lost the momentum from the 12th marks, but you have certain uh, belongingness in the brain, or in the say how did you did well when it was your first board exam, what was your source of motivation, or many cognitive factors are associated with 10th marks. So this 10th marks would be an indirect effect. Even suppose if I add 8th marks also, if I add 8th mark also, say C, okay, now if I add C3 to 8th marks, if I multiply C3 to 8th marks here, consider this as a collective thing. C3 is being added to the 8th marks, 8th standard marks. So don't you think that this 8th standard marks is definitely an indirect indication? This is an indirect effect. A person complete his or her 8th standard, and then after 4 years he or she is appearing for 12th marks, sorry, 12th standard. How would this will be directly affecting it? So this would be an indirect effect. This is the meaning of this overall projection of marks criteria. So it says if there is a effect like the feelings, or the how the book smells, or say how to approach a new mentor, if all such cognitive effects are being entertained, the 12th marks could be precisely predicted. So when we take into effect the direct and indirect effect of the previous time lag, we use autocorrelation function. So this is an example. But say suppose I want to go for a partial. So partial says that only, if I use a different color to it, it says uh, only direct effect of values in previous time lag, in previous time lag. That's it. On the current value, complete from the left. So see, only direct effect of the values in previous time lag. So can we say that at least for this data, time series data, only this yt minus 1, that is 88 marks, will have a direct effect? So for this we may write our equation to be 12th marks 12th marks as a y of t will be given as C1 times 11th marks plus error, plus overall error. That's it. This would be the equation for partial ACF, and here this bigger equation where the all indirect effects along with direct effects are being taken will be governed by ACF. So why were we using ACF and PACF? That it is going to give the order of the model. So this partial ACF is going to give the order, for it measures only the direct effect. Yes, it is used to find the order of auto regression model. This one. So if I am saying I want to find the order of AR, I'll go for partial ACF. And if I say I want to find the order of moving average, I'll go with ACF. Hope this is understood now. How to remember? AR for auto regression, partial ACF for auto regression. Or remember likewise, say suppose it starts with auto correlation function starts with auto, do not measures auto regression. Opposite thing, auto correlation function starts with the term auto, but it do not measures the order of auto regression model. This is how you can remember it. So say suppose if I give you a proper visualization regarding it. Let me see whether I have a space somewhere. Okay, it is done. It is done. Use of previous time lag is taken. And ACF and PACF plots. This again, another plot goes a bit high, and then plots goes okay, fine, sometimes negative also, and lower values. So this value actually indicates around 0.4. Here it indicates 0.6, and here it indicates 1.2, not greater than that because of the Pearson correlation coefficient. So it has a value from +1 to -1. So in this scenario, they are first lag, second lag, third lag, fourth lag, fifth lag, and sixth lag. So they are lags in the say data, lags in the data set. Means lags means again the past values of the data. So first and second lag, can you see it gives you a greater percentage of 60% of Pearson correlation coefficient as this one, and second gives almost 0.8. So this almost stand at 0.8 value, and rest of the percentage are being given as say this 3, 4, 5, 6, and they are the smaller one. So we won't take a greater than 40 or say 30%. So if I take a greater than 40%, then only 2 lakhs are significant. So I'll write significant. 2 lakhs are significant. And if this is a PACF plot, so please let me know which order it is being finding to. Is it finding the MA order or is it finding the auto regression order? Just remember, when you are finding auto regression order, the ACF also stands for auto correlation function. So auto do not counts auto. So PACF go for finding the auto regression order. So order of auto regression goes for 2. Makes sense because we have 2 lags as a significant lags in the history of the data. At the same time, if I go for ACF autocorrelation function and this one plot, it means that these 3 lags are actually significant. Significant lags. So here your ACF, which actually finds the order of MA. So we'll write MA having the order of 3 because 3 significant lags are found. So if we form our ARMA model, auto regression moving average model, we'll say we have a order of say P and Q value, P comma Q. So P value turns out to be 2 and Q value turns out to be 3. So this will be called as ARMA 2, 3. Hope it seems helpful. If this seems helpful to you, then we have another question to start with. Then what is ARIMA then? What is ARIMA then? If we are okay with the ARMA, then why this I term is actually being added to it? There should be something which ARMA is not helping us to solve the problem of trend, or must I say this problem of time series data. So we will say that ARMA, must I say ARMA and ARIMA, they both are almost. I can write ARIMA is almost ARMA, but just does one simple operation, that is ARIMA, just do one simple more operation of converts non-stationary series to stationary series. Now, what is the meaning of non-stationary versus stationary series? This says whenever a series means any value, any column, whether it's a sales or temperature or say money or any column in a data set is a series. So any series, if it is non-stationary, what is the meaning of non-stationary here? Say if I draw certain pattern, I'll say, can you see? I have drawn a trend which is having a certain seasonality in it. What else we can find here? One is seasonality, that after every time slot it is repeating itself, although increasing with time as well. So we can say the mean at this point is different from mean at this point. X1 bar at this point is different from X2 bar from this point, is different from X3 bar from this point. Again, the mean is changing, the average is changing. That is the moving average. We had a discussion from last module itself. So when the mean is not constant and a variance is not constant along with the seasonality, we say this is a non-stationary series. So to give you a proper indication, we say mean should be constant. Constant means it should either be oscillating about a common line. This can also be considered as constant in time series. Variance should also be constant. It should not vary, whereby along with both of them, the component of seasonality should be absent. When these three things, 1, 2, and 3, when these three things are met in for a series or for any column data, then we call such a column or a series to be stationary. Else that remains non-stationary, means it is changing its value, changing its mean, the variance is changing every time it moves ahead in time. So we cannot apply, must I say, time series analysis to a non-stationary series. So let me give you a very broad statement. So may I write here? We cannot apply time series analysis on any non-stationary non-stationary series or data or data. If this is the situation, we are bound to convert any non-stationary series to a stationary one. What is the meaning of converting to stationary? It says that whenever we convert by any means, we'll see how we do it. Whenever we convert any non-stationary to stationary, the changing mean becomes almost constant or oscillating about a single line. The variance of that data set is almost constant or varying around a single range, and the seasonality which was visible in non-stationary series is now absent, is not visible now. Then our ARIMA model is, must I say, or any model other than ARIMA or ARIMA whatsoever, they are eligible. Then our say our time series data is now eligible to be applicable for any of the time series model, because we have now converted our non-stationary series into a series, so sort of thing. So if I give a broad perspective to it, then let me clean it. Then I can write ARIMA. For rest of the two, we know it. This AR is for auto regression model, MA is for moving average model. But this I is actually called an integrated. We read it as integrated. And what does it do? It find the differencing, it do the operation, differencing operation to convert non-stationary series to a stationary series. That's it. Differencing operation. Always remember the term differencing operation. So hope now it is understood that this integration, this integrated term is not a integration. It is not the integration fx dx. Hope you remember from calculus. This is a different thing. This is a different thing. And this integrated is a different thing. Here we are actually calculating the difference, means we are finding the difference between the values. Like say, suppose if I had a trend, like say it is going like this. So this is called as a linear trend. Y of t is a linear trend. Now I want, and now it is a non-stationary. Now we can knew it because of the seasonality is also there, and variance and mean is also changing with respect to time. So when we apply a differencing to it, it becomes like this. If I use a different color to you, so it converts like this. So this term will now then be called as y of t minus of the previous lag. We just take a difference of the current values. So may I call it current values from the past values. So when we take a simple difference from the latest or recent past, we call it the first difference. The first difference. But when we also go for the higher differencing, say suppose in this differencing, mean has come into place here. If I draw a single line, the mean is actually oscillating within these two ranges, even the variance, but still the seasonality is not been eradicated. Then again, I need to go for differencing from y of t minus y of t minus 1. Again, y of t minus 1 shall be differentiated from y of t minus 1 minus y of t minus 2, and then take a difference of both, then this might, I'm not sure that this might say eradicate or eliminate would be a good word. This might eliminate seasonality. So we do first order differencing, second order differencing, third order differencing to check whether the seasonality is being removed or no, whether the seasonality is being removed or not. So these are the things, and I'll show you how these seasonality actually working for you, for us. Let's have the view. Try to see that these are actually the seasonality things. These are actually the stationary series. So if I write here, they all are stationary series. Stationary series. Non-stationary series we have already seen. Stationary series says, say a normal, this is called a white space, white noise has been created. So here, if this white noise, if I draw a line, so can you see how the mean is being distributed between +2 and -2, and especially between -1 and +1, other than few exceptional cases, even the variance. But we might face, or we might have certain, we are not sure about certain seasonality which is occurring likewise, say likewise. So again, we took one difference to it, random walk. We have taken a random walk, we given it a name, a random walk. So we differenced it from its previous value. So this is a difference, and see, sooner the difference is being taken, and I draw a line along x-axis at O, at origin O. So see, most of the seasonality has been eliminated here from as well. So even if you want to be pretty sure than this also, so you might go for one more uh, difference to create such a curve. So here, see, can you see the range? So this is actually oscillating between this line, no, without a seasonality, and no variance and no mean changing in this zone as well. So by the time you feel satisfied, it's okay. If you are not, increase the difference. Increasing the difference means, first initially you were taking yt minus 1 between the first lag. Now you may go for the second difference, second order difference. So yt minus 1 minus of yt minus 1 from its previous difference, t minus 2. So this is called the first order difference. This will be called as the second order difference. Similarly, when we apply the autoregressive process, this is how it looks like. And for moving average model, this is how it is look like. So these are the things to be understood, and they all are stationary series. They all are stationary series. So do practice with it, that how to identify a stationary series from a non-stationary series. Here is the final output, that how come this ARIMA model, if I write here, yes, ARIMA model final output. What does the final output actually represent? We will see right and left one by one. Actually, they both are same, but this is the must I call zoomed in version, zoomed in version of this, the right one. If you zoom in the right portion of the curve, it will come and look like this. So this says till this point, we were having the data. We were having the data. And this data actually contains a trend. Can you see trend? So what are the things we can apply over here? We can apply EMA, exponential moving average. We can apply weighted moving average. We can apply simple moving average, do not work now because we are headed mostly in exponential moving average and smoothen the curve to find the trend. So after applying EMA and WMA, we'll find the trend. Okay, the trend is uptrend, it is going up. But to do the prediction, must I say to do the forecasting would be the correct word. So till this point, so till this here, this is a forecasting. So forecasting is being done considering again two things. One is, and now if I'm applying ARIMA to it, sooner I am into the process of applying an ARIMA, it says, okay, please find the auto regression, means the relationship with itself. Go and find the moving averages. So from EMA, we find the moving averages and their orders. And this I, that is the differencing integrated, this will be used to convert such a non-stationary curve into a stationary curve. This is a non-stationary curve. So integrated functions means differencing function will curve this non-stationary to stationary. So converting to stationary. It will depend how many differences are being required, how many whether it's first order difference, second order or third order, to convert such a graph into such a stationary curve. And then you will feed your data to the model, which you shall learn in Python language, that how to apply it. But without converting it to stationary, we cannot apply time series. So ARIMA also take care of this. And then only the final output or the forecasting for after 1997 till 2001, the level of CO2 on Earth, will be forecasted. Okay, it says as the as it is observed from the past that it is increasing day by day, year by year, it is most probable that yes, it follows the same trend. And whereby it follows the same trend in with certain upper limit and certain lower limit. So here are the things which says this is the upper limit, or we call it upper bound, and this is called a lower bound. Means the forecasting says that this value, this red value, means the CO2 value, forecasted value, will might behave like this. Say if I use a different red only. So it says it might behave in this pattern for some time, or it might go till this point following this. Means this will have fluctuations not greater than this upper bound and not lower than this lower bound. So lower bound and upper bound also make a lot of difference. This is what the understanding from learning the ARIMA model makes to all of us. And hope this would have added a value to your understanding regarding the ARIMA model. So this is what all about the ARIMA model. If we go ahead and see that what are the things or the final touch to identify the ARIMA model. First of all, whenever you are supposed to be do the interrogation, actually it is a statistical model, mind it. It is a statistical model. That's the reason, that's the reason as a statistician or a data scientist or a data analyst, we cannot allow the measure of statistics, allow the measures, I should write S, measures of statistics to be non-stationary. Non-stationary. Had we ever done any calculation where the mean is varying continuously, where the variance is varying continuously? Had we done any calculation with population mean variable continuously, population standard deviation varying continuously? No, they have to be kept stationary. Then only the statistics makes a sense. Then only the estimates could be done. That's the reason we we started in statistics with point estimator, if you remember, point estimator, and turned our approach from point estimation to confidence interval. Confidence interval. And this confidence interval has only helped us today to find the upper and lower bound. Hope it makes sense. Upper and lower bound, this upper and lower bound on the right hand side. So being a statistical model, this is very much important for this. Then we say, please check for integrated thing. If it is non-stationary, convert it to stationary. So finding the difference. So taking the, or must I say, differencing between the lags, actually called integration or integrated term. So please take a deep breath and read this, and you will understand whatever we have done till now. This says the key components of an ARIMA model are autoregressive, that is AR, integrated IA, and moving average MA. Find first, second, and third. The AR component captures the dependencies between the current values and the past values in the time series. Mind it, dependencies. So while capturing the dependency, it was also finding the relationship. It is also finding the relationship of, must I say, past values to current values. Past values to current values using y of t equals to, say, any constant coefficient times y of t minus 1 plus error, suppose. Whereby the I component models the non-stationarity in the data. It models the non-stationarity, see, by taking one or more differences. One or more differences. If one difference is not able to convert non-stationary to stationary, mind it, stationary means the mean should be zero, or mean should be constant, not zero. Mean should be constant. The standard deviations under square root, that is called the variance, should be constant, and there should not be any no seasonality. No seasonality. So do the differencing till the time all the three are achieved. Then only we can apply the ARIMA model, whereby the MA component accounts for the dependencies between the error terms. So see the difference. Here the relationship of past value and current value is done in AR, and here the relationship between error terms is considered, and that's true in lag. Error terms is again past and present errors. It is considered into effect. So we should take care of while going to the ARIMA model that yes, what are we actually seeking towards? And this is how we learned the ARIMA model. This is a very important slide which says, okay, you learned a model, you allowed the model to learn from the data, or must I write model learned data. After model learned the data, it has given certain forecast. It forecasted the data as well, forecasted from the data as well. Then how would you measure the must I say the efficiency of the model, or accuracy of the model, or performance of the model? See, whatever prediction or the forecasting is done, if whether it is correct or no, how shall we going to ensure from this? So this, from our past experience, we can say we always use performance evaluation matrices like accuracy, like errors. In the errors, what are the errors we can consider? Mean absolute error, mean square error, root mean square error. These are the error we can concentrate about. We do not go for r square error. Why? Because r square error, do you remember the r square error deals with how the independent variable, that how the number of x, their variation, the variation in y, how much percentage of the variation in y is being solved by or explained by all the independent variable. Here we are having y at a this time and y at a previous time, that is the lags. So here that's the reason we cannot we do not use r2. We if we have a choice, you definitely go for r2 square, but we are actually comparing the previous values of the y to it to the current value of the y to find the future value of the y. That's why R2 score do not holds as much of significance as it is holded by MAE, MSE and RMSE. So measuring accuracy is done by these errors. Then we also compare the models after the performance they are being exhibited by them, after the it is exhibited by them. Then exponential smoothing, we go for finding exponential smoothing, moving average and ARIMA to find that which out of the three is best. So best out of them, basis of these errors. Then we also go for finding the stability, because stability is also important. So regularly evaluates the stability of your model over time. Means if you have developed a model or you have used the model, please provide different sets of data for the same domain to it and check whether is it able to regularly give the similar output or no, basis the pattern of the data. Because pattern in the data might change, so even that require the adjustment in the model. Sometime say irregularities also play a major role. Irregularities means those unexplained event and which do not even occur regularly. So if such things are being found, please adjust your data, remove it via decomposition methods. Then after doing all this thing, never forget to incorporate the feedback. Seek input from all the people who are responsible in your project, from the stakeholder and all the users who are using in the same chain line, to understand what is actually relevant out of the modeling you are started to do. So if your forecast, if the model which is being used for a forecast, if it has a relevant output, if it has a relevant output, then it's okay. But if it is not, if it's having irrelevant output, please incorporate the feedback. So hope this session for ARIMA, that's the
Your speaker is mute. I can't hear you.
am I not audible?
Yes, yes.
Yes, you are now.
Okay. Thank you so much. Okay, thank you,
Hello?
Sanish. So what I just said, that yes, now you would have been able to learn the ARIMA in the holistic view, that how this I term is actually helping you out in order to understand. Because say everything is okay, you went for PACF, ACF, you calculated all the say you measured all the time series component, but still if you are not able to remove the seasonality, if you are not able to remove the fluctuations in the say mean and variance, you cannot apply time series. So the most important thing was applying the time series. But how come? After removing the non-stationarity. And what is non-stationarity? The three things: the mean, the variance, and the seasonality component. So that was the thing, that was the order in which you should try to understand. Because see, it's a technical concept, I do understand that in the first go, in the for one shot, you might not be able to uh, digest the learning. At least look out the video twice, thrice, and in the say most possibly I would share the, may I call, the time series data itself, such that you can apply it. Would that suffice, Sanesh, Sudhish, Nikhil? What do you say, Abhilash? Any doubt in this?
It's okay.
Sudhish, you seems out to be some erroneous, some errors are there, some bug you want to solve. Any doubt, Sudhish?
Nothing, sir, but
Okay.
it's not my
Okay. So I believe things must have added a sense to you, that what is that, and how to actually understand looking at the data. Okay, this belongs to time series, this do not belongs to time series. Simple. If you want to apply anything, do want to forecast your company's sales data, you want to forecast your company's inventory, whether you should keep the inventory or no, just simply see the data, see is there a stationarity, non-stationarity, remove it and apply the time series. At least you can be a counselor to many, that whether the time series could be applied or cannot be applied. Simple. Keep the thing simple. So it comes only via practice. So I'll try to share the uh, time series data itself, such that you can plot it first and then check whether you can able to apply the time series or no. Would that suffice? Abhilash, Sudesh, Sanesh, others? Okay,
Okay.
great. Thank you for this session. And please come all of you to your dashboard, such that with the we can have our write today's screenshot pictures. All of you, Abdauji, Richard, Jinu, Jobin, Mohammed, Sriram, Nikhil, Kunal, come with your beautiful pictures. we are going to take the screenshot. Okay, Abdauji seems quite sharp. Good, Richard. Very good. Okay, all of you in this pose. Okay, going great. Thank you so much for your time, and we'll meet again once. What happened? Snip.
We can hear.
Yeah.
Prof.
So we'll meet again. I think right now, actually, I have converted this into what is called into Windows 11. So a new features are coming. New features are coming. Okay. So we'll meet again. All the very best. Take care. Bye bye.
Okay, sir. Thank you.
Okay.